Okay, guys, this is a session for your experiment 4, redox titration. And and in this experiment, you're supposed to do 2 series of titrations to find out something unknown. So when you, assuming you are doing your experiment, once you get into your lab, you will see 2 separate stock bottles, and then those ones have have labels with the names, and then there's another thing called concentration. So underneath the name, you should be able to see molar concentration, and then the molar concentration is given approximately. So the task for today, task for this experiment is to find out exact molarity of those 2 known solutions, which are potassium permanganate and hydrogen peroxide. So you'll need to do a series of titration for finding out exact concentration. And to do that, you have to start with something known to you. Because of that, you'll need to make your own standard solution using ferrous ammonium sulfate. Since we are asking exact molarity, you'll need to use 4 decimal place balance to start with, and then you'll need to use volumetric flask to find the exact volume. So by using exact mass, you should be able to convert into number of moles, and then using exact amount of your water, you should be able to calculate exact molarity of your standard solution. And then you do titration, and then once you find out the correct amount of titer, you should be able to find out molarity of first one, which is potassium permanganate. And once you find out the exact molarity of potassium permanganate, using the molarity from your first experiment, you move on to second experiment to find out molarity of hydrogen peroxide. And when you look at the first pre-lab quiz, so these ones are not actually given on your lab manual, but lab assignment. But when you look at the previous page, you should be able to find out 2 half equations. So this is stoichiometry of your first titration using ammonium ferrous sulfate and then potassium permanganate. So once you finish this one, and then you move on to second experiment, which is potassium permanganate with hydrogen peroxide. So you'll need to balance these one to find out the stoichiometric ratio to calculate your numbers later on. And then lastly, this is a just practice question. So you should be able to do it. So quickly, when you look at the first one, you just need to combine these 2 half equations into one redox equation. So when you look at first half, it has got only 1 electron over here, and the next one has 5 electrons. So you need to integrate using the number of electrons on both half equations. To start with, you just need to do this everything times by 5, and the next one should be times by 1. By doing this, you should be able to complete full redox equation. So first one should be 5Fe2 plus MnO4 minus plus 8 proton, and then I'll just write down the number of electron, 5 electrons, goes into 5Fe3 plus Mn2 plus 4 water, and then 5 electrons from this half equation, right? So when you look at the number of electrons, they have same number of electrons on both sides, so should we cancel them out, reading your final fully balanced redox equation. So you do the same for the next one. So it should be times by 2 here from the number of electrons from the other half. And then over here, it should be times by 5. So you do the same. You combine into one redox equations. So everything on the left-hand side, which are your starting material or reagent, goes here. Everything on the right-hand side, which are your product, goes here. Make sure that you use integers, otherwise you will have different number of electrons. And then for the last one, it will be quite straightforward because the number of electrons are the same, right? Although you can do the same way by multiplying by 2 and 2, right? Once you have everything, you also need to divide by 2 because that is not the lowest whole number. So either you do this or you just combine them into one redox equation because you have same number of electrons on both sides. 2 electrons here and 2 electrons here. So you just need to combine everything into one redox equation. And then in the end, you also should be able to cancel the common terms, which are 2 protons on both sides. Right? And then we do have multiple choice equations. So number 1 and 2 is really important for your lab, and answer should be both B. You always need to read the labels before you do anything because it is not really mandatory, but when you have a look at the labels on a bottle of chemical, you will see a lot of information. It's much more than you can imagine. And then number 3 is calculating molarity. So you should be able to do it without any trouble. So you will just need to convert this one into number of moles. Once you find out number of moles, you will need to divide this number of moles by volume in liters. So once you finish all the math procedure, you should be able to get a number and interpret moles per liter, which we abbreviate as large M, molarity. Right? Number 4, and it is all about stoichiometry ratio, which we're going to use in today's experiment. So my recommendation will be try to get your answer, and then once you finish everything, go back to number 4 and 5 and check again. Right. Now we need to have a look at section 1, which is about safety precautions. And when it comes to safety precautions, you'll need to have a look at a thing called SDS, safety data sheet, which is also included within the lab assignment. You'll need to download SDS for potassium permanganate and hydrogen peroxide from your assignment. You don't really have to download. You can just search the web page, and then you also should be able to find any relevant information. If you're familiar with any information on the web, use it. If not, you can use the one you already have within your assignment, right? So you should be able to find out all the information you need over there, handling, health, and disposal. And now let's jump onto the assignment. Okay, so since we need to get numbers in 4 decimal place numbers, we have to use 4 decimal place balance, and then other numbers are given. So mass of test crystal will be mass of everything here minus mass of wavelet, right? So when you do it, so 5.1111 minus 1.0797, you should get a specific number. And the mass of test crystal will be, I'm not sure. let me just put some numbers on my calculator. So 5.797. So I have 3.9214 grams. So you'll need to use this number for your calculation. And please read this one carefully. Some of the numbers over here will be used for your calculation later on. Right. So, and then you did 5 sets of titration, and then you should be able to get the amount of titer, and then you average the number over here. So I'm not gonna just do everything. I will just use this number as my average. So I'll put 19.45. So in liters, it should be 0.01945 liter, right? The reason why we are converting into liter is that we will need to calculate molarity, and then when it comes to molarity, everything has to be in liters, right? Okay, so let's have a look at the numbers we have. So molar mass, if you are in the lab, you should be able to find numbers from the stock bottle, but I want you to have a look at each individual atoms, and I want you to calculate. Once you finish calculating, please check your answer with any reference on the web page, and you even should be able to do using molar weight calculator or something similar on the web. Anyway, so once you do it, molar mass will be 392.14. Right, now looks at the number over here is just made up to make our calculation easy. Okay, so you need to find out number of moles in 3.9214 grams of fats. So to do it, you need to find out mass, which is already here, and then molar mass, which we already calculated. So moles should be mass over molar mass for that. So 3.9214 grams over 392.14 grams per mole. So look at the unit. First of all, that one cancels out, leaving only mole. So the mass operation is correct. So once you do it, it'll be 0.001. All right. Hang on a sec. So divided by 392.14. Yeah, should have one less zero. This is a common mistake. If you make a mistake on zeros, if you have too many or too little zeros, your number will be exactly certain times 10 or 100 times smaller or bigger. So you gotta be careful. So if you're not too sure, make sure that you use a calculator. Anyway, so let's have a look at the volume of H2SO for use for past standard solution. So when you go back to the procedure, it'll ask you to use 100 milliliter volumetric flask. So the volume you're gonna have will be exactly 100 milliliters. So which means that you have 0.1 liter of sulfuric acid solution. So I will write that it is 0.1 liter, right? So that's gonna be your volume. Now it is asking molarity. So again, molarity, which is large M or moles per liter. So you need to find the number of moles and then volume. So number of moles right over here, and then volume right over here. So we have enough information to calculate molarity over your standard solution. The molarity will be moles over 0.1 liter. So molarity will be 0.1 moles per liter, right? Which is right over here. I'll write the unit anyhow, moles per liter. Now it is asking number of moles of phase in 20 mils of phase solution. The reason why it is asking 20 mils of phase solution is that when you do your titration, so we have concave flask. It doesn't look like a concave flask. Now let me just draw this again. So now we have a concave flask, and then we have puree. We have got a valve. So in here, you're gonna put 20. You're gonna put 20 mils of phase solution, and then in here you have permanganate solution. So you are mixing these together to make it into perfect stoichiometric ratio, right? That is why it is asking number of moles of phase solution, right? To find out the molarity of this one. But this is known to you guys. Anyway, so number of moles of phase in 20 mils of phase solution. So you have 0.01 mole of in 100 ml. So either you can divide by 5 because it is asking 20. But to be precise, you will need to use molarity. So molarity or concentration equals number of moles of a volume, right? When you rearrange this one, N equals C times P, right? So using this equation, concentration is over here, which you already found out. So it should be 0.1 moles per liter times by volume, which is 10 ml. But you gotta be careful because the unit over here is moles per liter, so you gotta convert this one into liters, which is 0.02 liter. So, right, when you look at the mass of fraction, the liter unit cancels out, leaving only mole. So we didn't do anything stupid. So what we are doing is correct so far. So number of moles should be 0.002 moles. So you have 0.002 moles of phase in 20 mils, right? So now, next one, moles of permanganate. Use stoichiometry from your pre-lab question, number 1. From pre-lab question number 1. So when you fully balance the redox half-equations, it should be 1 to 5 ratio. So one of the permanganate will react with 5 Fe2 plus, making our final product, right? So when you look at the ratio, it's 1 to 5 ratio, right? That's what it says. So 1 mole of MnO4 reacts with 1/5 moles of phase. So using this stoichiometry, and then using the number of moles, you gotta find out number of moles of permanganate. So it is 1 to 5 ratio, right? So you just need to use this number, divide by 5, gaining the number of moles of your permanganate. So once you do it, let me just use a calculator because I don't want to make any more mistake. So I have 0.0004 moles. So that is the number of moles of permanganate in this situation. Finally, you need to calculate the concentration of your unknown, not unknown, approximately known permanganate. So to do it, you need to find the number of moles of permanganate, which is right over here. And then you need to find out the volume, which was from the average, Okay, over here I have close to 20 mils, but the actual amount I have is 1945, right? Liter over. Okay, so once you finish this one, so let's have a look how much you get. Divided by 1945. I have, and let me just put my calculator on the screen. So since it is asking to answer in four decimal place numbers, I'll write four decimal place numbers. All right, so when you look at the all the math operation, if we follow the significant figure rules, it should have different number of decimal place. But when it comes to say scientific report writing, and there's a hidden meaning. So if your number is always ends up with four decimal place numbers, it means you use four decimal place balance. If your numbers always end up with two decimal place numbers, which also can interpret that the guy who was doing the experiment was using two decimal place balance. So by using four decimal place numbers, it will just with us that your accuracy was four decimal place, right? That is why the assignment asked you to answer in four decimal place numbers. So in the end, I have this molarity, which is better than approximately 0.02 or something like that, because this number has much more precision, right? Okay, now once you finish this one, you need to move on to part B. So it'll be the same procedure, another titration in a conical flask with a burette. So previously over here it was fast, and then this was permanganate, and then this was known and this was unknown, right? But now in part B, you're gonna put hydrogen peroxide. Why it's not working suddenly? I'm gonna say, and then permanganate. Since we just finished calculating the molarity, this is now known and this is unknown. So it's gonna be the same fundamental. Using this number, you should be able to find out the molarity of hydrogen peroxide. Okay, so it's gonna be the same process. To find out the amount of tidal, you need to do simple calculation. Final minus initial will give you amount of tidal. Since I don't bother doing it, I'll just put the numbers over here, but please do your calculation. It'll be quite straightforward. So it was 20.05 mil. So in liters, it should be 0.0. Right, so let's move on to next page. So volume of permanganate is from part with titration. So I have this much in liters, and then molarity of permanganate, which was obtained from part A. How much was it? Okay, it was this much. Now it is asking number of moles of permanganate, and since we are dealing with solution, you need to use solution chemistry formula. Concentration equals number of moles of the volume. And then since it is asking number of moles, N equals C times B, right? So volume is already over here, and then concentration is over here, and then everything is in the correct unit. So you just need to multiply these two numbers, right? Once you do it, you should be able to find out number of moles of your permanganate. So let me just put some numbers on my calculator. I have 4.0041. So that is the number. I'm going to check. So it should put 0. That is the number of moles. And then it is asking number of moles of peroxide. Now from here, it should be the same process as we did in part A. You need to use the stoichiometry ratio from your previous question number 2, or you can just simply use this one over here. It is 2 to 5 ratio. So stoichiometry ratio should be 2 to 5. So to find the number of moles of your hydrogen peroxide, you need to use this one, this ratio. So once you have this number, you'll need to divide by 2 first, and then times by 5 using the stoichiometry coefficient, and you should be able to find out the number of moles of your peroxide. So using this number, let me use the same number here. And divide by 2, and then times by 5. So I have okay. So if you need to write your numbers in quotation mark place, and then your number is your number ends up with 0, you still need to put 0 because it tells you that you still have 4 decimal place number, which also represent that you are using 4 decimal place balance, right? So once this is done, the remaining ones should be quite simple. So the number of moles of hydrogen peroxide is right over here, so you just need to use this number. And then volume of H2O2 in the part B titration, so it should be somewhere in your description, but it is the titrant over here, so it should be 20 mil, right? So still needs to be in liters, so it should be 0.02 liter. And then molarity. So to find the molarity is C, or molarity is number of moles over volume. So number of moles is over here. Divided by the volume in liters. So let me just do, no, sorry. I need to put my question onto the computer calculator. My mistake. Right. So using the number of moles and then divided by volume in liters, which is 20 mil. So I have so this is the number of moles of hydrogen peroxide. And yep, this is the last page. Okay, so this is it. So once you finish this one, please go back to the previous presentation on the stoichiometry ratio and how to do it, and then you should be able to cross-check whether you did the correct or not. Right? All right, so that's it for week 4 lab. And if you have any questions, please feel free to send an email or contact me via Microsoft or Teams, and I should be able to answer any questions you have. Right, thanks, guys.